Square is inscribed on a circle. Write the area of the square as a function of the radius. And so what we need to know is, what does it mean that a square is inscribed on a circle? So what that means, if you don't remember from your geometry days, inscribed means that it's contained inside of the shape. So what we have is we have a square on the inside of a circle. And the radius goes from the inside of the circle, from the center of the circle out to the edge. Right? Now, I drew it that way, but truthfully, I should have drawn it like this. I should have drawn it through this way. Now, why does that make a difference? Well, if I want to think of it like this, I could have a triangle that has the radius and the radius. Okay? But what I really want to figure out is this length here. That's what I really want to figure out. Now, your textbook, you could use a geometric proof to prove this thing, or we could start to flex our trigonometric skills, because this is a special trigonometric right triangle. Do you guys know which one it is? If I have, it's isosceles, but if I have a side length and a side length that are the same length, what would this be?
R squared.
Well, somebody already said it.
R plus R.
Shh. In order, here's what I want to tell you guys, and you need to be careful. In order for this angle to be, this angle alpha has to be equal to beta, right? In order for them to have the same side lengths, right?
Yeah.
Okay, now, we're making an assumption, and we might be correct, we might not be correct, but we're making an assumption that this is 45 degrees and this is 45 degrees. Now that's only true if this is a 90-degree angle. Now, since it is a square, if I draw the diagonals across the square, I know that this angle and this angle are congruent. I know that this angle and this angle are congruent. We also know that this angle plus this angle has to add up to 180, just like this angle plus this angle has to add up to 180. Well, in order, if all those angles are congruent and they always have to add up to 180 and that doesn't change at all, then we, and I'm just kind of skipping ahead just for time's sake, because we're not required to show the geometric proof, it's safe to say that this angle is a 90-degree angle. And so if this is a 90-degree angle, then these two are 45-degree angles. So now I can solve the hypotenuse by using the, we could use a trig function, or we could use Pythagorean theorem, which some of you guys mentioned, which would mean that the hypotenuse is equal to r squared plus r squared, and then you take the square root of it, right? Because a squared plus b squared equals c squared. Okay? And this is the c squared or h, or however you want to call it. We could call it the side length s of the square. So really what I have is I have s is equal to the square root of 2r squared, which is the same as the square root of 2 times the square root of r squared, or s, the side length, is equal to 2, the square root of 2 times r. And what they're asking us in problem number 18 is, well, first, now that we figured out what the side length is, it said the square is inscribed in a circle. Write the area of the square as a function of the circle. Well, the area of the square is s squared, which is the square root of 2 times r, all of that, squared. So when I squared the square root, in other words, I would say the square root of 2 squared times r squared. Or a is equal to 2 times r squared. And that's our answer. Does anybody have any questions on that?